Hello, today we are going to explain one of the applications of the differentiation, which is a curve sketching. Okay, example, analyze and sketch the graph of fx equals 2 x power 2 negative 9 divided by x power 2 negative 4. We are going to divide our solution to 3 parts. The 3 parts, one of them is concerning the fx, the other part concerning f prime x, and the third part concerning f double prime x. Okay, let's work for the part of fx first. The first point I have to do here is to replace the fx with a 0. So I'm going to replace each fx or whatever, fx equals to 0, and then I'm going to factorize the top and the bottom of the equation. So it's going to equal to fx equals 2 brackets x power 2 negative 9 divided by x power 2 negative 4, and we are going to equal to 0, and we are going to start to factorize the top and then the bottom. Okay, for x power 2 negative 9, the factorizing is going to equal to x negative 3 times x plus 3. And for the part x power 2 negative 4 is going to equal to x negative 2 times x plus 2. Okay, let us start to determine what we can find from the part of fx. We can determine the vertical asymptotes from the bottom of the fx. Okay, so the zeros of the vertical, or the zeros of the top, the bottom, I'm sorry, is going to be the vertical asymptotes. So we can write the answers or the zeros or the values of the bottom side. It's going to concern the vertical asymptotes. Okay, so I'm going to write right now the asymptotes, which is going to be the 0 of x negative 2 is going to equal to x equals 2, and for the part x plus 2 it's going to equal to what? X equals negative 2. So I'm going to write x equals to negative 2 first, and the other one is going to equal to what? To 2. Okay. Concerning the horizontal asymptotes, which is the second one I have to find, we have a case here. The case is what? The case is the degree of the top and the bottom is the same. So we're going to make it like 2 divided by 1 equals to 2. We're going to use the coefficients, okay? Not the variables. So we're going to use the coefficients of the same degree of the top and the bottom. So we are going to write the 2 divided by 1, which is going to equal to 2, okay? This is the coefficients of our value. So y equals to 2. Okay, third part, x-intercepts. Let's go to the top again. So for the vertical asymptotes, it's going to be, or we're going to determine the vertical asymptotes from the b, or from the bottom, I mean, okay, which is going to equal the zeros of negative 2 and 2. But for the top, we can determine or to find the x-intercepts the same way. Okay, so we're going to take the zeros, which is going to equal to what? To negative 3 and 3. Finally, we are going to find the y-intercepts, but we have to plug in, okay, the value x equals to 0 in our equation, and we're going to find, after plugging the value of x equals to 0 to our equation, the main one, okay, the main function, we're going to get that y equals to, after we can do it here, okay, by doing 2x power 2 negative 18, it's going to equal to 2 times 0. I'm not sure you can see what I'm doing right now, but at the same time, we have no idea. Okay, plug in the 0, negative 4, so negative 18 divided by negative 4 equals to 18/4 equals 9 divided by 2, which is going to equal to 4.5. Okay. So we are going to write here 4.5. Okay. Let's go to the other part, or part number 2, f prime x. So we are going to do this part, okay, on the board, on the other board here, please. So we're gonna wait, or just discussing what we can find from this part. Okay, we can find from this part, after finding the differentiation of our function, the critical points, or your intervals, your intervals. When you're going to graph, you're gonna find your intervals, so you have to find the critical points. Also, you can determine from the f prime double x, or I'm sorry, f prime x, okay, if your first differentiation is going to be greater than 0, so it's positive, which means increasing. Okay, and if f prime x lesser than 0, this means negative, so decreasing. And finally, if your fx, your differentiation, first differentiation, equals to 0, this means relative max or minimum. Okay, what we can get from the third part, or the third column, f double prime x. After finding the f double prime x, okay, we can get test values, okay, and also we can find some conditions here from the f double prime x. F double prime x, if it's going to be greater than 0, this means plus, okay, concave up. Also, for number 2, or the second part, f double prime x, if it's going to be lesser than 0, so this means negative concave down. And finally, the third one, if fx, or f double prime x, equals to 0, this means inflection point. So I'm going to review what we are doing here on this chart, okay, before going to the steps of how to find the first differentiation and the second differentiation. Okay, as I told you before, we are using here 2 parts. The first part is for algebra to solve the fx, and the second part is solving the differentiation, second one and the first one, I mean. Okay, so by using calculus. Okay, so this part using calculus and the other part is using algebra. Okay, first of all, I have to say we can determine from the fx 4 parts: vertical asymptotes coming from the bottom of the function, the main function; horizontal asymptotes, in this case we have the same degree, so we're going to write the coefficient 2 divided by 1, which is going to equal to y equals to 2. The third part, x-intercepts, and we can find the x-intercepts from the top. Okay, the zeros of the top is the zeros of the x-intercepts. And finally, number 4, y-intercepts, you have to plug in the 0 in the main function here, so you can get y equals to 4.5. For the second part, or for the second column, after finding the first differentiation, we are going to get the critical points, so you have intervals to graph your sketch, okay? This point is going to determine your intervals. And you can find also the decreasing and increasing of the function. Also, you can find the maximum or the minimum of the relativity, okay, here in this part. The third column and the third part, you can find the test values, okay? At the same time, you are concerning about, in this part, concave up and concave down, inflection point. So, this is the summary of our question. Let's move to the other part. How can we get the f first prime and the second prime? Thank you.